Hello students, welcome back. I am Rinkesh sir, mathematics teacher at Lux School of Science. Okay, so students, we have started with chapter number 3. We had completed till exercise 3.3. Now, before starting exercise 3.4, right, we will learn some operations of matrices. I will name it as elementary operations. There are six different operations, means three for the rows and three for the column. Okay, so first we will study the basics of these operations, then we will study about invertible matrix to find out the inverse of matrix. Okay, so let's start with the first operation, elementary operation of matrices. Conversion, I will not say conversion, we will just change one row to different. Okay, altering the rows. Like I will write down R I to R J. This means that we will exchange the ith row with jth row. Okay, for example, if this is a matrix A, 1, 7, 2, 3, 1, 5, 4, minus 1, minus 3. If this is a matrix, if I apply R2 to R3 or R1 to R2 or R2 to R3. This means that we have to exchange the first and second row. So by applying this operation on this matrix, we will get okay 3, 1, 5, 1, 7, 2, 4 minus 1 minus 3. Clear? Okay, see what I did? I exchanged row 1 and row 2. So if you are having any equation like on the LHS there is one matrix, on RHS there is one matrix, okay, and when you apply this, then you have to exchange the row 1 and row 2 in both the matrix, one on the LHS and one on the RHS. Okay. Similarly, you can also use the exchange of column. Ci to Cj means you are exchanging ith column with jth column. Means in that if it is C1 to C2, then we have to exchange these two columns. Clear? The second one is multiplying elements of any row or any column by a non-zero number. Okay, see how we can represent this. I can represent is as Ri to Kri means I'm multiplying ith row with K. Okay, see in the similar matrix A, I will take same 1, 7, 2, 3, 1, 5, 4, minus 1, minus 8. Remember, I am not multiplying this K with whole matrix. Okay, I am only multiplying with this row, ith row. Means if I am saying R2 to 3R2. Okay, so what will be your answer? 172. The second row, elements of second row only will be multiplied by 3. Means 6 minus 2, 10, 4 minus 1 minus 3. Right? Okay. See, I am not saying that this is matrix A. Clear? Now this is matrix A. This is not matrix A, but this matrix is formed by applying this operation on matrix A. Clear? So this similarly you can also multiply by the element of column. Right? That will be Ci to KCI. Means the ith column, each element of ith column you will multiply by K. Clear? So two properties for rows, similarly for column. For rows, similarly for column. Now third, Okay, what happened in third? We can multiply any row with a non-zero number and then add that row to some other row, right? And same way for column also. Let's see how we can do it. How we can represent it? I can represent Ri to Ri plus 3rj. That means multiply the jth row with 3 and then add that elements with the ith row. Also for the column, let's take it as a non-zero constant k. Remember, here k is not equal to 0, even here. Clear? So now, again taking this same matrix, that is 172, 3, 1, 5, 4 minus 1 minus 3. So what I am applying? I am applying this operation like R2, that is 2 into R1, sorry, R2 plus 2 into R1. So see, I am transforming this row, second row. How? That elements I am taking R2 plus 2 R1. So now what I have to see here? We need to change only row 2. So first and third row, write it down as it is. 1, 7, 2, 4 minus 1 minus 3. Now for R2, first multiply the row 1 with 3. Right? So what we do, it's 1, 7, 2. So it will be 1 into 2, 2, 7 2 is 14, and 2 2s are 4. And multiplied row 1 with 2. Clear? And then add these numbers to row 2. Now what is row 2? 3, 1, 5. So add these numbers. So 2 plus 3, 5. 14 plus 1, 15. And 4 plus 5, 9. Okay, so see, I am repeating what we have to do. R2, here it is given the operation on R2. So other from R2, the other two rows I am writing as it is. The only thing that you have to change is on R2. Don't get confused that here R1 is given, so you need to change R1 also. No, focus on this. So whatever row or column here it is, apart from that, write down other rows or other columns as it is. Okay. Now we had left a blank space for row 2. Now what we have to do first, multiply row 1 with 2. I multiplied it on side and then add row 2 here. So this answer will be here. Clear? So this is the third operation. Similarly, you can apply it for column also. Okay, so these are the three elementary operations. Actually, it's six. Three for rows and three for columns. Okay, so just note it down. Okay, next is invertible matrix. The next portion that we will study here is invertible matrix. Okay. Invertible matrix means if A is a matrix, then A inverse. Okay. Just like multiplicative inverse. The multiplicative inverse of 5 is 1 by 5. That means 5 into 1 by 5, this will be equal to 1. Clear? Multiplication inverse of 7 is 1 by 7. Right? So I can write down this as 5 inverse. So now for invertible matrix, if I take matrix A such that, or if I take two matrix A and B such that AB is equal to BA, that is equal to identity I. Right? In that case, we had taken that 5 into 1 by 5 equal to 1 by 5 into 5, and that was equal to 1. Identity, right? So, similarly here, if AB is equal to BA, that means A must be multiplied by B. Multiplication of AB must be possible and also equal to BA. Then it is equal to I. Remember that inverse of only square matrix is possible. Clear? And I'm not telling that every square matrix will have inverse. I'm telling inverse of only square matrix will be possible. Of rectangular matrix, inverse is not possible. Okay, so let me take one example. Let me take the value of AS 2, 3, and 1, 2. Okay, so for B, I am taking example of 2 minus 3, 2 minus 3, and the other one I can take it as, let's take minus 1, 2. Okay, see, I have taken these two matrix as I know that this is inverse. I have not selected this randomly. Okay, I have not selected these two matrix randomly and then it will be equal to y. Okay, so I have selected two such matrix which here B is inverse of A, right? So I already knew it that B is inverse and by that I selected B. Randomly you cannot select two matrix and say every time it will be equal to I. Okay, so now let's find it out. AB means 2, 3, 1, 2. What is B? 2 minus 3 minus 1, 2. Okay, so let's take first row 2, 3. 2 is a 4. Uh, 2 to the 4 plus 3 ones are minus 3 ones are 3 minus 3. Clear? Minus 3 into 2 minus 6 plus 6. Okay, now it's time for second row. 1, 2, 2 ones are 2 minus 2 minus 3 plus 4. So this will be equal to 1, 0, 0, 1. So this is equal to y. Okay, now let's find it out BA. Okay, what is B? 2 minus 3 minus 1, 2. Remember, it must be square matrix, then only its inverse is possible. Let's take first row. So this will be equal to 2 to the 4 minus 3, 3 to the 6 minus 6. Let's take second row minus 1, 2. Okay, minus 2 plus 2 minus 3 plus 4. So this is also equal to 1, 0, 0, 1, and this is equal to I, 2 cross 2. I2, I can write on it as I2. That means identity matrix for order 2 cross 2. So now here AB is equal to BA is equal to I. That means B is equal to A inverse. Okay, so I can write it down. A inverse is equal to, if A is equal to 2, 3, 1, 2, then A inverse 2 minus 3 minus 1, 2. Clear? So this I have only taken as an example. You are not going to find out inverse of matrix by this way. You cannot select randomly any matrix. Okay, so this I had just proved it using example. Okay, so by this way you can find it out. Sorry, by this way, if AB is equal to BA equal to Y, then the other matrix is called inverse of first. Okay, clear? So just note down this point. Okay, next, uniqueness of inverse. Okay, means if there is a matrix A, if any for any matrix A, for any matrix A, if AB equal to BA equal to I, so what does that imply? A is equal to A inverse. Clear? And also, if AC equal to CA equal to I, so that implies C is equal to A inverse. But if you find out like this, then it will be always like B is equal to C. That means these both are same because inverse of a matrix is unique, means there cannot be two inverse of a single matrix. If it is so, then both that matrix will be same. Clear? So this property says about uniqueness of inverse. Okay, so note down this point. Okay, the next main important theorem is about inverse is A B whole inverse is equal to B inverse into A inverse. You can be asked in descriptive that two matrices are given and verify whether AB inverse is equal to B inverse into A inverse or not. See, this is B inverse into A inverse. It is not A inverse into B inverse, right? You know, in matrix, AB is not always equal to BA. Sometimes it may, right? But not every time. Okay, it depends on the values. So most of the time you will observe that in questions ABA is not equal to BA in matrix. So it's B inverse A, right? First multiply A and B and then inverse, and then B inverse into A inverse. Okay, so now let's prove it. But before that, I will tell you one more important property. A into A inverse is equal to A inverse into A equal to I. How? In previous, previously we studied today that A B equal to B A equal to I, then B is called inverse. So instead of B, I am writing A inverse. Okay, so we will be using this thing here. Okay, so let's start to prove this. Okay, so what we will do first, we will write down that AB into AB inverse, that is equal to I. Okay, AB into AB inverse is equal to I. So now what we will do, we will multiply both the sides with A inverse. Okay, we will multiply both the sides, means A inverse AB, AB whole inverse, A inverse into I. See, I had multiplied both the sides with A inverse. So A inverse, I will just take it out this outside. A inverse into A into B into AB inverse, A inverse into I. Now, when you multiply any matrix with identity, the resultant will be same. Like if you're multiplying A into I, it will be A. Any matrix B into I, it will be. Any matrix C into I, it will be C. Right? So A inverse I, this will be equal to A inverse. Okay, clear? So now let's move. What is A inverse into A? Right? A inverse into A is equal to I. So I can write it down I B AB inverse is equal to A inverse. Now again the same property. Multiplying identity matrix with any matrix, the resultant will be same. So I am just copying it down here. Instead of I into B into AB inverse, I am writing B into AB inverse. Okay. Therefore, is equal to A inverse. Okay. Now multiply both the sides with B inverse. So this will show that B inverse into B into AB inverse equal to B inverse into A inverse. Say I am multiplying both the sides B inverse and B inverse. Right? I cannot write down here A inverse into B inverse. See, the trend that I am using here, I must use same. Clear? So now what is B inverse into B? I. So AB inverse is equal to B inverse into A inverse. So identity matrix multiply, the answer will be same matrix. So this shows that AB inverse is equal to B inverse into A inverse. Okay, this is just a theoretical proof that AB whole inverse is equal to B inverse into A inverse. Clear? This type of question would not be asked in descriptive portion. Okay, if it is asked, then it would be in this way that two matrix A and B might be given. Then you have to prove this. So how you have to prove? Take LHS, multiply both the matrix, find out its inverse. Okay, for RHS, find out B inverse, find out A inverse, and then multiply. Now, how to find out inverse? We'll study in the next video lecture. Okay, so at present, just remember this is very important property. And one more thing that for any matrix, when you will multiply it with I, it will remain same. And any matrix multiplied by with its inverse, I'm writing down here that any matrix multiplied or IA is equal to A. And second, any matrix multiplied by its inverse is equal to identity matrix or A inverse A into I. Also, these are very important. And this one, okay? Just note it down. Okay, so students, that's it for today, right? So based on these elementary properties and uniqueness of inverse and this, we will solve exercise 3.4. First, we will use this elementary operation to find out inverse of 2 cross 2 matrix, and in the next video lecture we will try to find out or we will study the method to find out the inverse of 3 cross 3 matrix. Okay, remember inverse can be found out only of square matrix. You cannot find out inverse of rectangular matrix. Okay students, so that's it for today. Thank you.